Hi, my name is Massimo Banzi and I'm one of the co-founders of Arduino. Welcome to this series of video about the Arduino Starter Kit. In this particular video, we're going to start learning the basics of all the components we're going to use in the rest of the videos. So what we see here is a set of electronic components, and today we're going to build a very basic circuit. We're going to use a small LED connected to a button, and when you press the button, the LED comes on. It's a very simple electronic circuit that doesn't involve our Arduino board at all, and it's designed for you to understand all the basic elements that make an electronic circuit. So what is an LED? The LED is a small source of light. You can imagine it's like a light bulb, but it's more efficient because it doesn't generate that much heat because it's an electronic component based on a semiconductor. So LEDs are very convenient for us because they work at a small voltage. So they can be powered by a small battery or the voltage that you can get from an Arduino board. So what is a circuit? A circuit is a series of electronic components like this LED or this button connected together using wires. Electricity can flow through the components, and each component is either able to transform the electricity into something else, like light, like the LED does, or, for example, the switch is a component that can open and close a circuit when you press on it. This particular button that I have in my hand, it keeps the circuit closed until I press the button, and then it closes the circuit. Closing the circuit is like a little bit like when you open a tap. You let the electricity flow through the button. Electricity, you can imagine, is like water, and the wires that we are using to make the connections are like pipes. So the source of electricity is essentially the equivalent of something that pushes water into the pipes. So the first circuit that we're going to build is going to have a source of electricity pushing the current through the wires, a number of wires that connect to the button. Then the button will open and close the circuit, and when the circuit is closed, the current will flow through the LED. And then we will use another component that I have here called resistor. What happens is that the voltage of our battery is too high for the LED that we are using. Just to give you an idea, we're going to be using a source of electricity operating at 5 volts, which is the standard voltage at which the Arduino board operates. But this LED is only going to need about 1.7 volts. So how do we make sure that the LED doesn't take too much current? Well, we're going to use a resistor. And this resistor is going to limit the amount of current that flows through the LED, keeping it at the optimum amount of voltage and current. How do we make the connection? Well, actually, what happens with circuits is that you can take wires and you can wrap them around and you can create circuits like that, but that's not very practical. If you want to do a lot of experimentation, if you want to move components around, if you want to try different kinds of circuits, wrapping wires around is not exactly the best idea. So what we're going to do, we're going to use this component that you see here. It's called a breadboard. The breadboard essentially provides a set of pre-arranged connections, and each one of these holes is actually connected underneath with a metallic spring. So when I plug a wire into the breadboard, the spring will hold on to the wire and it will connect to all the other holes in the same line of holes. So let's have a look. For example, this line of holes that I am pointing to at the moment, they are all connected together. So if I plug this wire in this hole, all the holes in the same column are going to be connected to this wire. So if I take, for example, this resistor, and I plug the resistor in one hole in the same line, for example here, this is okay. So at the moment, the resistor and the wire are connected together. If I move this wire to the hole next to it, they are not connected anymore because only the wires in the same column are connected together. So to explain this concept a bit better, I have prepared here a circuit that contains a lot of all the basic elements that I told you about. This is the resistor, this is the push button, this is the LED, and this is a wire. So what's missing here is the source of power. What a circuit needs in order to operate is a source of electricity. In this case, we're going to use the Arduino board as a source of electricity. The Arduino board can be powered through a battery or through a USB connection, as you can see in this particular situation. We're not going to use the intelligence provided by the Arduino board. We're just going to use the power that you can take from the Arduino board in order to learn how to build the circuit on the breadboard. So we're going to connect this wire to the other leg of the resistor. You will notice that actually the holes on this side of the breadboard, they have a different pattern. So why is this? Because actually these two lines of holes, they follow a different connection pattern. So the ones that cover the main area of the breadboard, as I said, are all connected along the column, while these lines are going all the way from one end to the other. So these are two separate strips of holes, and each one of them is connected together. So for example, if I plug this red wire at the beginning of this line of holes, I'm actually connecting 5 volts to every single hole that you can see on this line here. So this means that the resistor is now connected to this hole. Now I'm going to take this black wire and I'm going to plug it in one of these two holes that are marked G and D. G and D is the ground. It also represents the minus on your battery. If you look at the battery, normally there's a plus and a minus. So 5V represents the plus on this ideal battery, and the minus is here represented by G and D. So if I connect the black wire to the other line on the breadboard, now I have connected 5 volts to the first lines of holes, and the black wire to the second line of holes. Now, if everything is done correctly, if I press the button, I'm going to connect the resistor to the LED. This will complete the circuit and the LED will light up. Wow, okay, it's working. Okay, that was good. So the ability to convert electricity into another physical phenomena that we can actually experience in the real world makes the LED a transducer. So the transducer is a component which is able to convert electricity into something else, or, for example, if there were a component that would convert light back into electricity, that would also be a transducer. In particular, we call the LED in this particular situation an actuator, because it takes electricity and then turns into something that I can actually see in the real world. In this case, I can see the light. Electricity is invisible to me, but the LED makes electricity visible by turning it into light. We have our completed circuit, and I would like to make some modifications now to introduce some other concepts. So what we are looking at here is a very simple circuit where each component is connected to the next component in the circuit, and then the last connection goes back to G and D. So you can imagine the current flows from the red wire into the circuit, through the resistor, through the push button, then in this wire, then through this LED, another wire back to ground. So this is how the circuit is closed. One of the features of this circuit is that the elements, we say, are connected in series, because one component comes after the other. And we can make this circuit a little bit more complicated, because at the moment we have only one button. So what happens if I connect another button? So I can remove this jumper, and then I'm going to add another push button, making sure that it's connected with the LED. So now when I press these buttons, nothing happened, because the circuit is still open. We have to close the circuit using one of these wires. So I will plug the wire here, I will plug the other wire here, and if everything works out, I press the button and still nothing happens. Why? Because these two buttons are connected in series, so they are one after the other. If I want to operate the circuit, I need to press both buttons at the same time. So look at this. When I press button number 1 and button number 2, the current is able to flow through the circuit, and when I release one of the buttons, the circuit is open and it stops operating. So what we have learned now is that if we put buttons in series, so one after the other, I need to press all of them in order to close the circuit and make this electricity flow. Inside the push button, there are two pieces of metal that are separated by a spring. When you press the button, these two pieces of metal, they come in contact and they create an electrical connection and the electricity can flow through them. When you release the button, the spring pushes the two pieces of metal away and it interrupts the circuit, it opens the circuit. So you will notice that the push button has got 4 legs. At the moment we used only 2. What are the other 2 legs doing? Well, actually, they are internally connected to the first set of legs. So the 2 legs on this side of the push button are internally connected together, and the 2 legs on this side of the push button are internally connected together. So this increases the number of combinations that you can use when you create circuits. And so what happens is that if I take this jumper that I use to build this circuit, I can actually mount it behind the push buttons, and the circuit still works. So what you will notice is that this point in the circuit and this point in the circuit are exactly the same. And here, this point and this point are exactly the same. So when I press the button, these 2 points in the circuit are connected with these 2 points in the circuit. When I release the button, only these 2 points are connected and these 2 points are connected individually, but there's no connection between the 4 of them. So this allows me to try to create another connection that we call parallel connection. The idea is that we can actually place one button next to the other, and we can create 2 different paths that the current can use to actually flow through. Let's see what happens if we put these 2 push buttons in parallel. So what I'm going to do, I'm going to use 2 jumpers. So I'm going to connect one leg of the first push button with the same leg on the second push button, and I'm going to do the same for the remaining contact, 1 and 2. So what happens here is that if I press the button, now the LED comes on. And if I press the other button, the other LED comes on. And if I press both of them, the LED comes on at the same time. So what's happening here is that by creating 2 different paths for the current to flow through, I just need to press one of the 2 buttons for the current to reach the LED and light up. If you put the buttons in series, you need to press one button and the other button in order to create light. And in this particular configuration, you need to press one button or the other button in order to turn on the LED. So in a way, this small circuit is creating a very basic logic circuit. One that has an AND logic. You need to press one button and the other in order to light up the LED. And the second one is an OR circuit. You press one button or the other. That's all for today. I hope you enjoyed the tutorial, and remember, build it, hack it, share it, because Arduino is you.